All right, hello everyone. This is the relearning video for Unit 3, Week 1. This was our introduction to proportional relationships. We had 4 learning targets this week. The first one was determining if a relationship in a table was proportional. So the way to do that is to check every single row by dividing backwards. If they give you the same number, then it is proportional. If they do not give you the same number, it is not proportional. So if we are looking at this first one here, actually I'm going to do the second one first because I think it's easier to make a point here, okay? We talked a lot about the constant, COP, goes with number 1 in the left-hand column, because 1 times anything is that number. So if 1 is going with 9, that means if this was proportional, it would be times 9. So then you just check it. Is 5 times 9 40? No. So that one right there is not proportional. On the next one, again, you are going to divide backwards. So 10 divided by 6 would give you 0.6. And then the next one, 20 divided by 12, also gives you 0.6. 30 divided by 18 also gives you 0.6. So that one right there is proportional. You would have to check all 3 of those in your calculator. Okay, obviously I was the calculator there. But make sure you are putting the number in the y value first, because you're going backwards. So start with the y divided by x. All right, on the next one, this one is just finding the constant. Well, I just told you that because it's the same table, okay? So you do 10 divided by 6. If I just want you to find the constant, that means it is proportional, okay? So 10 divided by 6 is 0.6. That right there is your constant. All right, the next learning target was to use a constant to find unknown values in a table. So your biggest key here is understanding that there are 2 steps. Number 1, you have to divide backwards to find your COP. Number 2 is then using that COP, we are either multiplying forward, because that's our relationship, is x multiplied by something gives us the y value. Or if you're working backwards to a box on that side, you are dividing, okay? So the first thing we're going to do is we are going to find our COP. So we're going to do 15 divided by 12, and I believe that gives us 1.25. So from x to y, it is a times 1.25 relationship. That is our COP. And then to find our missing values, okay, the yellow boxes, if we are finding our missing y, you ask yourself, is that going forward or backward? That is forward. So you will do 15 times your COP of 1.25. And I believe that gives you 18.75. Let me double check that. Desmos. 15 times 1.25. Yes, 18.75. Okay, and then finding the missing x value. So if we're finding this value, that is going backwards. So we are going to divide by our constant of 1.25. Now, be extremely careful here. When you are plugging this into the calculator, it is number in the table first, and then the COP, okay? So you have to do 22.5 divided by 1.25. And let me plug that in. That is going to give you 18, okay? Number in the table first, multiplied or divided by the constant of proportionality. All right, and last one here, and this is finding the constant and explaining the meaning in context. So finding the COP, it's that same table that we've already done. 10 divided by 6 is 0.6. Look at that. I'm going to have to change. Let's delete that. Okay, had to change the context. We are going to make it make sense if we're talking about gallons and miles. All right, so we are going to divide backwards. We are talking about gallons of gas and miles traveled. So we have to divide backwards. So 138 divided by 6, that's going to give us 23. Okay, now the most important thing, the reason I left a blank row is that when you find that number, that goes with the 1 and helps you find your sentence. Okay, so we always start our sentence with for every 1. That's not going to change. For every 1, well, what's the 1 talking about? Gallon of gas. There are, what is your COP? In this case, it's 23, and that is talking about miles traveled. I mean, you can make that sentence make sense a lot of different ways. You could say 23 miles per gallon, 23 miles for each gallon. For every 1 gallon of gas you can travel, you can go 23 miles. Make it make sense, but as long as you have your 1 and your constant and you understand what those numbers go with and you can make it make sense grammatically, you are good. All right, that is it.